So, now we have to calculate the capacitance of a parallel plate capacitor. Suppose you have taken, this is a parallel plate here one, this is the another parallel plate, placed non insulated stand, and this is given here the positive charge. So, here are the negative charges due to induction. Between these two placed medium is air or vacuum, we can take electric field is in this direction. Suppose charge density is here plus sigma and here is minus sigma. Distance between two plates is d and A is here area of plate. So, A is here the area of plate here. So, now we can write electric field intensity. If you see the electric field intensity outside these two plate over here or here, you will be getting 0. Because of this plate, electric field intensity is going to this side, and because of the positive it is coming to this side, and both the density charge densities are equal. So, net electric field intensity is over 0 here and similarly over 0 here. But if you take the electric field intensity between the plates at any point, you will be getting E is equal to sigma upon twice of epsilon naught plus sigma upon twice of epsilon naught, and you will be getting here sigma upon epsilon naught, and this is here E naught. So, direction is here from positive to negative, and we can write here also, suppose the charge is q on these plates. So, we can write here q upon A epsilon naught, because sigma is equal to q by A, that is the charge surface charge density. So, this is here electric field intensity between the plates. Now, we can write the potential difference between the two plates. We know the relation between electric field intensity and potential difference. So, we can write area of plate is known to us. So, we can write here V is equal to E naught into D, that is the potential difference between the two plates. E naught can be written here sigma upon epsilon naught into D is equal to q by A epsilon naught into D. Now, this is the V potential difference. Now, we can take here C is equal to q upon V. So, we can write C is equal to q upon q d here upon A epsilon, q cancel. So, C is equal to A epsilon by D. So, capacitance of this parallel plate capacitor is given to here, C is equal to A epsilon naught upon D here. Now, which depends on the area of the plates and distance between the two plates. And also, if suppose the dielectric material is placed between these two plates such that it covers the complete or this entirely empty space here, then the capacitance can be given in that case. If the material of dielectric constant K is placed, then we can write here C dash is equal to here K A epsilon naught by D, or we can write here C naught K, C K here. So, capacitance increases by K times if we place here dielectrics between these two plates.